Mi nombre es Sebastián González Valdés.
Yo soy José Trinidad Cervantes Romero.
Estamos cursando la materia de matemática 004 en GAC.
Ahí está Sebastián midiendo el ángulo, como pueden ver.
We're going to calculate the distance about the end of the road to the, the minimum distance in the building. And we're going to calculate the height of the building. Okay?
Yeah. Okay, so I'm going to explain you how to calculate the length from the building to the end of the rope and also the height of the building. Okay, so here we have our building. And here's the rope. Here has an angle of 39 degrees. Here of 90 degrees, and here of 51 degrees. We know that the rope is of 26 meters, and well, firstly we need to classificate the angles and the sides.
So this is the angle A, this is the angle B, this is the angle C, this is the side A, this is the side B, this is the side C.
We're going to calculate first the length from the building to the end of the rope. So we're going to use this. So A over sin of angle A, it's equal to B sin of angle B. We're going to substitute A is X because we don't know it. Sin of angle A is 39, and this is equal to 26 over sin of angle B, that is 90. Okay, so we're going to find the sin of 39 and the sin of 90. This is equal to sin of 39, it's 0.62. Okay. And now we change this, it's 26 for the 26 meters, okay? And here is the sin of angle B, that it's 1 because it's 90. So here you can see sin of 90, it's 1. Okay, so we're going to with this we're going to calculate x. Okay, we're going to multiply this for this and then divide it into 1. Okay, so it's 26 for 0.62, it's 16 with 16.12. Okay, so we know A it's equal to 16.12 meters. So here. And now we're going to calculate the height of the building. Okay. Now for this we're going to use the same method but with side C. Okay. So it's sin or sin of angle C, it's equal to A over sin of angle A, that this is equal to X because we don't know it, we're going to calculate it right now, over sin of angle C, that it's 51, equal to A, that now we know that it's 16.12 over sin of angle A, that is 39. Okay, now sin of x, sorry, sin of 51 degrees is 0.77 is equal to 1612 over sin of angle of 39 degrees, it's 0.62. Okay, and now, like in this one, we're going to multiply this times this and divide it by this. Okay, that is 16.12 times 0.77, it's 12.41 divided into 0.62, it's 20.02. So angle side C is equal to 20.02. This is the height of the building. This is the height of the building.
Eratosthenes of Cyrene, most known as Eratosthenes, was a Greek mathematician, geographer, poet, astronomer, and music theorist. He was a man of learning, becoming the chief librarian of the Library of Alexandria. He invented the discipline of geography, including the terminology used today. He is best known for being the first person to calculate the circumference of the Earth.
So, now I'm going to explain you how my friend Eratosthenes, I don't remember his name, but let's think that it's Eratosthenes, how he calculated the circumference of the Earth. Yeah, our nice and beautiful planet Earth. Okay. He already knew that the Earth was a sphere. It's kind of sphere. Don't laugh on me. Okay. But he discovered that there was a water hole in a part of the Earth that in some that in one day of the year at a specific time, the sun entered directly on the hole. You know, let's see that this is the sun, and so there was no shade. Okay, but then he discovered that there was a tower in another part of the world, and the same day of the year at the same time, obviously the next year, because it was a little bit far away, he discovered that at the same time, the same day of the year, when the sunlight entered directly into the water hole, here it create a shade. Okay, so this create a shade. So the angle that the shade created, it was of 7.2 degrees. Okay, this angle. So let's imagine that this is a pose, and so because here's a because of the congruence of angles, this angle is the same that this. So this is 7.2. Okay. So he paid someone to walk from the waterhole to the tower. This person calculated by his steps and things like those that from here to here there was a distance of 800 kilometers. Okay, so because it's 7.2 for 800 kilometers, we make I think it's almost the same in Spanish. A rule of three, a three of rule, I don't know. 7.2 for 800. So 360, there is a circumference, it's for x. So 360 multiplied by 800 divided by 7.2, it's equal to 360 times 800, it's equal to 288,000 divided by 7.2, it's equal to 40,000. Okay, so the circumference of the earth is of 14,000 kilometers. But this is approximated distance because now we know that it's of 40,062 kilometers. Look at this, it's too exactly by how he did it for the real circumference of the earth. Thank you very much.